All right, let's see. I think it's only me. All right, well, I'll get started here with the Zoom session. And I'm going to be talking about Module 8 specifically. All right, let's have a look. All right, so we're looking at Module 8. What I recommend you do is look into the soft chalk first. So soft chalk exercise for Module 8. We get to Module 8 folder here. And that would be up here, Module 8 soft chalk. Go through that, do the interactive exercises as well, and then start on the Module 8 assignment. So let's take a look at what's in the Module 8 assignment. Now the Module 8 assignment is set up pretty much the same way as the Module 8 soft chalk is. And a lot of the questions are set up as tables. And this is the way that we solve these problems in the Module 8 soft chalk. We do the mass of the element, the moles of element, divide by the smallest moles, use a multiplier, and then find the empirical formula that way. I'm actually going to do a couple of examples of this in a second. But a lot of these are multiple choice, so it's just a matter of finding which table is actually the right one here. Right, so you'll do that for the Module 8. Now remember that the Module 8 assignment also has video answers for all of these problems as well. So I recommend that you look at the videos for the Module 8 assignment if this is something that you're having trouble with. But if you are just doing this without doing the soft chalk first, I think you're going to have a lot more trouble. Okay, let's return to content here. So as I just said, these are the assignment problems here, and these are the videos for the assignment problems. Okay, so for all of those. So what I want to do was go through the Module 8 practice quiz. I'll do those examples. Okay, so you'll notice that these are all multiple choice pretty much. So what I want to do is just go through them. So for the first one, what is the formula of a compound formed from 3.00 grams of iron and 1.72 grams of sulfur? So the way I do this is I would set this up as a table on a separate sheet of paper. We'll have the mass in grams. Then we'll have the moles. Now the moles are going to be defined by, for iron would be, let's see, moles of Fe would be 3.00 grams times 1 mole over the molecular weight, which is 55.85 grams. And we get that off the periodic table, of course. Now, when we do that, just pull up a calculator here. We get 0.0537 moles. And for the sulfur, we do 1.72 grams times 1 mole over 32.07 grams. Again, that's the atomic weight of sulfur. And I get 0.0536. As you can see, those are going to be pretty close. The next thing is to divide by the smaller of the two. And that would be, in this case, 0.0537 divided by 0.0536. Sorry about that. Probably a little bit trivial here, really. This is 1.002, or say 1.00 really. 0.536 divided by itself would be 1. So you can see that the mole ratio here isn't going to need anything. It's just going to be FES. So for that one, we didn't really need to do anything with the multipliers. I think what I might do is I'm actually going to see. I'll show another example of the practice test as well, in order to get to this after I've done this modulate practice quiz here. Now, what can happen though is, let's say we got to this point and it was, I'm just going to erase some stuff here. If I can, hang on. There we go. All right, let's say we got to the divide by smallest part, and we came up with 1 and 1.33 as being the numbers we get there. This is what sort of concerns students a bit in this situation. Well, you don't just round the 1.33 down to 1. What you need to do is you need to look at the decimal part and figure out how you can make that a whole number. So what we need to realize here is that we need to know the decimal conversions of certain fractions. So we know 0.25 is equal to a quarter. We know that 0.33 is equal to a third. We know that 0.5 is equal to a half. And we know that 0.66 is equal to 2/3. And we know that 0.75 is equal to 3/4. So what we would need to do in each of these situations is multiply by whatever number would make this a whole number. So we have to be aware of these fraction to decimal conversions so that we can do that. So if it's 0.33, I'd multiply by 3. If it's a half, I'd multiply by 2. If it's 2/3, I'd multiply by 3. If it's 3/4, I'd multiply by 4. If it's 1/4, I'd multiply by 4 as well. So if it's 1.33, I'm multiplying by 3, but I have to multiply both by 3. So it'd be 3 and 4, which would make it Fe3S4 in that instance. So you have to be very aware of how to convert these decimals. Now, if it's close to the whole number, like 0.98 or 0.01 or 0.02, we can just round to that number. We don't have to do any multiplication. But in this instance, when it isn't a whole number, or close to a whole number, then we've got to be able to multiply by something to get that whole number. But what's really important here is to make sure we multiply both by the same number. So 1 times 3 and then 1.33 times 3, which would be 4. All right, does anybody have any, well, actually, I think I'm the only one here. Yep, so nobody has any questions. I'll continue on. Okay, question 2 here. we're looking for the percentage of Fe in FeOH3. So I'm not going to do the whole thing here, but to get the percentage of Fe, it would be the molecular weight of Fe would be 1 times 55.85, which is off the periodic table, of course, because that's for 1 by Fe. There's only 1 Fe in FeOH3. And that's where the 1 comes into play. And then this will be over the molecular weight of FeOH3. And that'll be multiplied by 100%. And that'll give us the percentage. So whichever one of those is closest, that'll be the one you'll pick. For the percentage of water in a hydrate, so we're looking for the percentage of H2O here. In ZnBr2.3H2O, it'll be 3 times 18.02, and that's the molecular weight of water, H2O. And the 3 there is because there's 3 of them here in the hydrate. And over here, this will be the molecular weight of the entire thing, ZnBr2.3H2O. Now, if in the soft chalk I go through a hydrate and what that is, but it's going to be, to get the molecular weight, it's going to be Zn plus 2 times Br plus 3 times H2O. And that'll give you the molecular weight. And we multiply all of that, of course, by 100%. And again, whichever one of these is closest, that'll be the one you'll pick. Question 4 is about true formulas. And the true formula of something is going to be based upon the empirical formula. Now, the empirical formula is OH, which means the true formula can be any whole number multiplier of that. So it could be OH, which would be OH1, or O2H2, O3H3, etc., etc. But we are given here the actual molecular weight. So what we can do is we can figure out the weight of the empirical formula, which is going to be 17 grams per mole. How do I get that? Well, oxygen is 16, hydrogen is about 1, so it's about 17 grams per mole. So what I do is I take the molecular weight, which we're given in the problem, and divide by what I'm calling the empirical weight, EW, to see how many empirical units I can fit into the molecular weight. So that would be 34 grams per mole divided by 17 grams per mole, which is 2. So I can fit 2 of these OH units into the molecular formula, which makes it H2O2. So that would be my final answer there. So if it was something like, let's say it was NO2, and we found there were 3 units, then it would have been N3O6, for example. So it's all a matter of just looking at the empirical weight divided into the molecular weight. You can get more information about this by looking at the soft chalk as well. Yeah, it's just me still here. All right, let's look at an oxide problem. Now, with oxides, it says an oxide is prepared by burning 4.00 grams of chromium in air. The mass of the oxide is 7.69 grams. Now, that oxide is not oxygen. The oxide is some compound of chromium and oxygen, which has some sort of molecular formula. I'll say it's CrXOY. So if we have the mass of chromium, the mass of oxygen here is going to be the oxide which is this, by the way, minus the chromium. So that would be 7.69. Whoops. Minus 4.00, which would be, hang on, let's get that 7.69. Okay. That would be 3.69 grams of oxygen. So it's really important to make sure that we do this subtraction step in order to get the oxygen here. So when I'm doing my table here, I do chromium, I'll do oxygen. The chromium is still 4.00 grams, so that's the mass. The oxygen is 3.69 grams. The moles, so that'll be, let's see, I'll just do some quick math here. 4 divided by 52, that's the atomic mass of chromium, 1.08. And for oxygen, 3.69 divided by 16. And that's 0.23. 1. Then what we do is we divide each of these by the, I'm not sure, this is 4 divided by 52, is that right? Whoops. No, I think I did that wrong. I see 4 divided by 52. 0.15, yeah, sorry about that. That's a typo there. So 0.153, 0.154, that seems more reasonable. And then we can go ahead and divide by the smallest. And that would be 1. And then 0.231 divided by 0.154. Which should be 1.5. Now, as I said earlier, you've got to look at this 0.5 here, figure out how you want to make that a whole number. Now, 0.5 is equal to a half as a fraction. Sorry, my pen is not working here properly. So 0.5 is a half, which means I multiply both of these by 2 to make it a whole number. So that becomes 2 for the chromium and then 3 for the oxygen. So it'd be Cr2O3 would be the final molecular formula for that one. That'd be the answer you'd pick. Okay, so let's look at number 6 here, the empirical formula containing percentages. Well, those aren't very much different than what we've just been doing. We've got Fe and we've got S. And we look at the percentage first, and the percentage is actually going to be the number of grams if we had 100 grams. So we just assume we've got the same number of grams as we have the percentage. We just assume we have 100 grams of compound, so grams will be the same as the percentage. Right, then we just go ahead and do what we did earlier, get the moles. And for iron, let's do that first. .5 divided by 55.85. Again, the atomic weight of iron, 1.14. And for sulfur, it's 36.5 divided by 32.07, 1.14. You can see we can divide by the smallest here. It's going to be, well, it's going to be the same. It's going to be 1 and 1. So it's going to be FES for that one. So That one's fairly easy. No fractions or anything to take care of. And the last one here, 25% and 25.9% and 74.1% O. We'll have N, we'll have O. So the mass is going to just match the percentage because we're, again, just going to go ahead and assume we have 100 grams of compound. And then we find the moles. 25.9 divided by 14.01. 1.85 for the moles of nitrogen. For the moles of oxygen, 74.1 divided by 16, 4.63. Divide by the smallest. And we'll get 1. And then 4.63 divided by 1.85. That'd be 2.5. So now, since 0.5 is equal to a half, we'll multiply both of these by 2. That'll be 2, that'll be 5, and 205 will be my final answer for that one. So that's pretty much it. All right. Well, since there's nobody here, I'll just say goodbye and hopefully somebody will watch this.